So, good morning, everyone. Last week, we started learning a little bit about variables, or not last week, but the prior session, we started learning about variables. We got our text editor set up. We got a bunch of stuff set up now in our environment. So, we're going to start diving into different data types in Python. So, data types are a really important thing to know because no matter what kind of data you're working with, it is defined by the computer as a specific type. And knowing what type of your data you're working with, what operations you can perform on those data types, how to manipulate those data types, those are all really important aspects of the language. So, the first data type that we're going to be focusing on is one of the more common ones, and it's called a string. So a string is just any text or character. So if this was being printed, this is a string. This is a string. A string can also include things that are typically not considered a character string, like text. So you can put three in quotation marks, and that is also considered a string. So we'll dive a little more into what exactly that means, how it's useful, and what differentiates it from other data types. So last session, we created an alias for Python focus group. So you should be able to type PFG and it should now actually take you to the Python focus group directory. So this should make it immensely easier from this point going forward every time I tell you at the beginning of a session to navigate. I'm going to paste that session 5 in one more time. So we're going to go into session 5. If you do not have a session 5 already, which I imagine you don't, go ahead and just make a session 5 directory and then change into it. So make session 5 and change into it. Now, if you notice here, if I say ls, I only have this markdown file, which is this thing right here. I don't have any script, so today I get to actually follow along with you all. So we're going to go ahead and make a new file called strings.py. And last time we learned that we can actually open this with our text editor. So I'm going to navigate to where I have my GitHub stuff. So remember, for Windows users, this is under Documents. I'm not sure about Mac users, but I think it's also under Documents. But you can go to Documents, GitHub. I see my Python focus group. I can go to session 5, and I see that I just created this file. So I can open strings.py. So I'm going to be moving the notes to another window since we're going to be interacting more with the text editor and the command line today. So I'm going to format that really quick on my side, just so I can see what I'm up to, but we'll still be following the notes. Okay. So remember at the top of the scripts, I always recommend that you just put this interpreter. So as a brief reminder, that looks something like this, where it tells the file that you're writing in Python. So this should be in the markdown file. But after we've told it that we're running Python, now we can have some examples of strings. So I'm going to type a comment and say examples of strings so that I know what I'm looking at. And we can say string 1 equals hello world. So going back to what I talked about with syntax highlighting, we see that this is now grayed out. That's because it is a string, and that's how the text editor is interpreting this. I want to note really quickly, see how string, if I don't have that number, turns purple? That's because that's actually a function, and we'll talk about that later. So don't just put string equals or you're going to override your function. So I recommend just putting something like string 1 equals hello world. So now we can save this file. And if we run it, so we say Python 3 strings.py, notice nothing happened. And that's simply because here, all we did was assign this text to this variable. So the Python script that's running is like, yep, that's stored in string 1 now, and that's it. So we haven't told it to print anything or to do anything interacting with us. So we're going to add some other examples of strings and talk about each of these things. So maybe string 2, we can say spring is coming. String 3, we can say my dog ate 3 slices of pizza. And string 4 will say, I can't believe my dog did that. So the reason that I've chosen these different examples is because there's a lot of different characters going on in here that are used for other things in Python. So for example, just moving forward, if I say example variable is 3, notice that now this is red. That's because this is an integer. But up here we see 3 and it's grayed out. But that's because we put it in the strings. So we're essentially saying, I want you to treat this 3 as a character, as text, rather than as a number. And this is important because as we go on later into the session, we'll learn that there's certain operations and certain things that you can do specific to strings that you can't do with other data types. So if I wanted to, let's say, view any of these, I could say print, let's just say string 4 as an example. So now if I run this, it's printing string 4, which is storing, I can't believe my dog did that. And it's printing exactly like that. So the next thing I want to talk about is escape sequences. So maybe I should really quickly talk about some of the benefits of using strings. Just put it in perspective a little. So let me find a Python file. There we go. There we go. So any of these grayed out things are strings. So we see sequence, type, there's this print generating search patterns for, and then a variable. And this is actually some syntax that we're going to cover today. It's called an F string. So this is really helpful for any time you're working with data where you're trying to find specific values. So in this case, I'm iterating through a CSV file where I'm looking for specifically the word guide. So strings are helpful if you're working with CSVs, you're trying to subset your data to only certain pieces of the data, certain types. They're really important, but sometimes your stuff is not going to be formatted very nicely. And this is what escape sequences are for. They're for formatting things in a way that are helpful and actually conducive to doing research. So let's now print escape sequences and say, I'm in such a good mood today. I'm going to quickly put session 5 back in the chat and see some other people joined. There we go. Okay. So we talked a little bit about an escape sequence last time, but I didn't talk about what different kinds there are or why we do it exactly. So notice now, if I put the parentheses, or not parentheses, apostrophes on the side, and then I have another apostrophe in the middle, it's now thinking that only this part is the string and everything else is actual Python function. That's not really the case. So what we can do is tell Python specific instructions to say, I want you to interpret this as a character. So we can say this little thing here, this backslash forward slash, I think it's a backslash, this backslash, this interprets it as a string. So it's saying this is a character and it is a string. It is not a function. It is not for syntax purposes. So you're giving it instructions. So let's take a look at the difference really quick. If I print this, it's going to yell at me. Yeah, it says unterminated string literal detected because it thinks that this is one string, this is code, and then this is starting a new string, which is why it says unterminated. It's saying this string doesn't end anywhere because you have an odd number of apostrophes. But now if you tell Python, no, I want you to treat that character as a string, and we try that again, it prints without a problem because we're giving it instructions on how to deal with that character and essentially telling it the data type. So there are other things we can do with this as well, which are kind of fun. So let's say we want to print roses are red, violets are blue. If we just print this, it's all on the same line. This is a poem. We don't want it on the same line. So there's actually some different types of characters you can use. And so this is in the session 5, but this -n can be used to start a new line. This -t inserts a tab. And as we just discussed, this backslash just makes it a literal character. So I'm gonna give some examples of those now. So if we have this roses are red, violets are blue, but we want this on a separate line, we can actually put that backslash n. And as Python is reading this string, it recognizes this sequence as a new line. So now if we save the file and rerun this, we should see that these are now on separate lines, despite the fact that we've written it in the same line. So this is helpful for cleaning code if you're printing multiple outputs, if you want to separate things in a way that's visually pleasing to look at. So another thing you can do is like printing progress of your script. So you can say loading, ... And then you can say -t, and the -t is a tab sequence, and you can say done. So now if we print that, notice that there's this big tab sequence here. So that's what this -t is doing here. So there's all sorts of little things you can add into strings, and this is especially important if you're doing any sort of path traversal. So a lot of things that I use include paths. So up here, for example, I'm running this Python file for Nick and I think Camille's data actually. But I give it a name for the guide RNA I'm looking at, and then I can give it a sequence. So this is a string, this is a string, and we'll go into argparse later, but we can see that I've told it that the type of these arguments is a string, whereas the type for this argument is an integer, because I'm going to do math with an integer, but you can't do the same kind of math with strings. So strings are really common. And as I said, using stuff like paths is really common. So if I wanted to include a path for Windows, let's say I have this. Oh, it might have fixed itself now. No, there we go. So it's confused. It says there's an escape sequence that's truncated. So this is the escape sequence. It doesn't really know what it's doing. So this is actually a problem specific to Windows. All of the paths are kind of backwards compared to in, let's say, Macs, where it's all forward slashes, which alleviates this problem. But there's a trick where you can say, instead of having to go in front of every single one of these and code it literally, you can just put an R at the front of this, and it tells Python, treat this whole thing as a raw string. So now when we print it, instead of yelling at us, it's like, yep, here's the path. So this is helpful for navigating different directories specifically. So there are also other things that we can do with strings. There's actual direct string manipulation. So let's say that you are creating a figure, and whether this is in R or Python, there's similar functions in both. But if you're creating a figure, you want your axis titles to look pretty. You don't want your underscores and all your formatting kind of funky. So you can manipulate your strings in ways to make that work as well. So manipulating strings. So we'll create something that says original string is Vicky is teaching me how to code in Python. And that's our original string. So let's just print the original string and see what happens. So we should see Vicky is teaching me how to code in Python. But let's say I am putting this as the title of my slide, of my figure, of whatever, and I want all of it to be in pure uppercase. I want to draw attention to it. I can actually say, I'm going to define a new variable and say original string dot upper. So this is our variable, and what I'm telling it to do is attach this function called upper that acts by turning everything in original string uppercase. And I'm assigning that to a new variable. So I'm saying take original string, make everything in uppercase, and assign it to upper string. So now if I print upper string, we see that we've manipulated the string. Maybe zoom in a little more on that. Yeah.
Vicky?
Yes.
Could you give an example that is maybe relevant to genetics where it could be really useful?
Yes, so this is really useful in like say FASTA files. So you're searching for a DNA sequence in reads. I'm going through a BAM file, I have a FASTA file defining my sequence. If you're trying to search for any sort of pattern matching, this could be case specific. So let's say these are like A, C, G's, and T's, and your FASTA file is, we'll give a quick example. So let's say sequence one, we'll say ACGT, and sequence two is ACGT. We can say sequence one equals sequence two, and I think that will tell us if it's true or false. So we'll print if sequence one is equal to sequence two. Yeah, so it prints false. But this is a problem because even though these are the same base pair identities, cases are getting in the way of it. So typically what I like to do in a case like this is just turn everything either all uppercase or all lowercase. So I'll do like seek.1 upper and then seek.2 upper. And now when I try this, it's true. So this is really helpful in cases like that where you're trying to find like specific matches for either base pair identities or something of the sort. So making sure that cases are consistent is kind of important. And especially in a lot of FASTQ files, you might see that there's like a mix of uppercase and lowercase letters, which also throws something into it. So just saying like, you know what, make everything uppercase or make everything lowercase just makes it easier because then everything is consistent for your searching. We'll do DNA. We'll keep. Yeah. As a brief recap, if we run that, this is false because the cases are different, but this, when we turn them both uppercase, is true. So yeah, that's an example specific to genetics, I say, that makes this stuff relevant. There's also other functions, so you can say like lower, so lower turns everything lowercase. So we can say lower string, and instead of upper, it's lower. So we can say print lower string, and this turns everything lowercase. And then in the case of, let's say, plotting, you can use title case. So I think you can say, instead of lower, title, title. So this is all manipulation, but in a good way. So yeah, this is title case. Vicky's teaching me every first letter is capitalized. So another thing that I find really helpful is replacements. So an example of this that I can try to pull up, and this is more in R because it was what I was working with yesterday, but it's the same function. Like you're using a substitute or a replacement function. So let me go to my repositories. This isn't actually Amira's data. I just labeled it wrong at first. This is Camille's data. Okay, so I was making volcano plots for some different things yesterday, and I was reading in file names. So I was basically saying, read in these file names, and notice that there's like all sorts of things like underscores and spaces and results and CSV. But I want to do a dynamic read-in. I want to be able to format the title for essentially every single one of these different files. So I'm able to manipulate the string in a way that makes it look pretty. So I'm telling it down here, take the file name and replace the underscore results with nothing. Replace the end CSV with nothing. Replace Wilcox lemma with nothing. Replace everywhere we see GFP underscore positive with a GFP plus. Replace any place where we have no underscore construct with GFP minus cells. Substitute any place with an underscore with a space instead. So what this means is it's essentially taking my string and replacing pieces of the string to make it pretty, and I can do that in a loop dynamically so that it's actually reading in nicely and I don't have to format it manually for every single one of the items I'm working with. So let's do an example of that. Replacing strings. So remember that the original string is Vicky's teaching me how to code in Python. So we're just going to print that again down here. But what we can do is create a replacement string and say original string dot replace. Now, unlike these functions where it's already defined what you're doing, replace needs an actual argument. So you need to tell it what you're replacing. So the first argument is what you want to replace. So I'm going to replace my name, Vicky, with the internet. So it's going to search that string, and every instance where it sees Vicky, it's going to replace with the internet. So now if we print that, so print replace string, we see that we have replaced my name with the internet. So this is really helpful, again, for formatting, if you're trying to search for something specific, if you're trying to just make things kind of look pretty in plotting, especially for visualizations. If you're doing any sort of like publication quality figures, you want it to look good. You want your axes to look nice. You want everything formatted really pretty. So a lot of these operations seem very basic, but they're really helpful for kind of those prettying up and aesthetics things with coding. Or even in this case, like some of these functions are helpful when you're actually searching for like sequences or doing something. So there's another thing we can do, specifically called stripping spaces. So stripping spaces. And I'm going to show you some examples of what this looks like, and then I'll talk about some of the use cases here. So I'm going to make a variable called space out and say space. I'm going to put caps lock on as I type this really quick. There we go. Dang, it's harder to type wrong than I would have expected. Okay. So there's different functions you can do. So what we're gonna do is strip spaces. So this is common. Let's say I've run into this issue a lot in R and Python, actually. If I'm reading in a CSV that somebody has formatted, as you're typing a CSV, there might be a trailing space at the end of your column name or at the beginning of your column name that you don't perceive because it's just a space. You're like, yep, the column name is sequence name, but you're not perceiving that there's blank space at the beginning or end of it. So this has caused a lot of issues if I'm doing an RNA-seq analysis, for example, and I'm reading in a count file with the names of the sequences and trying to replace it with the sample name I want for the analysis. Because a lot of times we'll see in RNA-seq, the count file names are following the submission. So it's like KB1, KB2, KB3, but that's not really informative. We want it to be replaced with like cortical organoid, day 90, wild type, or something of the sort. So when I'm trying to do that matching, those spaces really, really mess with the column names because I'll be searching for a specific column and it's like, yeah, that column's not found. So then I end up having to strip the spaces off the column names, and then finally that matching occurs. So it's really similar to something like this where something small like the title case makes a really big difference in the ability of the program to identify that those things are the same. So in this case, we're going to strip the space on the right. So we'll say unspaced out dot r strip. So now if we print, let's say spaced out and right strip, you should see theoretically nothing because we stripped the space on the right. So yeah, they look the same, but functionally these two things are different. This will look more noticeable when we strip the space on the left. So stripping the space on the right is r strip. You can also do left strip equals spaced out dot l strip. So this strips all the spaces on the left, and then we can print that. So print left strip, and this should be more noticeably different. Yeah, so this took the space on the left away so that it got rid of the white space. Now I'm gonna try something. I remember back in the day that I used the strip function and for some reason I took it out. I think there was an issue with it, but we're gonna explore. So spaced out dot just strip, I think should strip all of the spaces in the entire word. So we'll say strip spaces. No, that didn't work. Yeah, so I remember back in the day, there used to be a function that's strip that would just take out all the spaces. I don't know why exactly they replaced that function. Maybe they just replace it because replace serves that same purpose. So we can say, let's say spaced out dot, instead of strip, replace, and we'll just replace every instance of a space. And then we put a comma for the next argument and say nothing. So we're saying take all the spaces out and replace it with nothing. So now it takes all those spaces out of our string. So yeah, that strip used to be a function. Again, I don't know what happened. But there are ways to go around it. Usually there's a lot of redundancy, and one thing you'll notice with coding is you can give 5 people the same simple task to accomplish, and every one of them will code it some way different. So that's kind of fun. Okay. So I'm going to take a brief pause to talk a little bit about function notation. So you might have noticed in other cases, there's functions that say like length, and then you put length of the thing inside. But in the cases of what we're working with today, we're putting like the thing dot upper, the thing dot lower, the thing dot replace. This is actually because we're working with objects. So every data type is considered an object in Python. So a string is a specific kind of object. And these, like upper, lower, these functions are specific to strings. So like you can't say uppercase or lowercase on a number like 3. This only works for any sort of characters. So as a result, if you're working with an object and you want to apply a function to that object that's specific to the type of object you're working with, you append it at the end. And this is not super important. This is something you're probably going to run into that should be a quick fix. Like if I say spaced out, my name is Vicky, and then I just say print upper spaced out, I think this is going to yell at me. Yeah, so it's like upper is not defined. So even though upper works here, it's not defined here because I'm using it as a function wrapping something instead of putting it at the end of something. So that seems like a really nitty-gritty kind of thing, but it's really easy to tell. I'm like, I wanted to make something uppercase and it told me it's not defined. Oh, maybe instead of putting it on the outside, I'll just put it at the end and see if that works. Also, I'd like to point out, if you're ever in doubt, you can also just Google it. So like I can say how to use upper function Python. Now with AI, it even gives you an example. But yeah, you just tag upper at the end of it and it tells you that's how you use it. You can say text.upper. It'll give you some examples, and prior to the AI days, you would just open whatever popped up and look at it. So you'd be like, oh, yep, dot upper, sweet. So yeah, if in doubt, just Google it. There's so many different functions. I haven't even probably touched half the functions that I can in Python, but I just want to make you all aware that these exist and there's ways that you can go about that. So now we're going to shift focus to indexing, and I want to also show this because this is kind of a helpful schematic to have. Depending on the language that you're coding in, you either have 0-based indexing or 1-based indexing. Now, one of the complicated things is Python and R have opposites. So in Python, we use 0-based indexing, meaning everything starts at 0. So when we have like a string called index arrays, the first letter is actually called position 0. So if we want to print the first position, we're actually printing position 0. If we want to print the 5th position, we're actually printing position 4. So it's the position we're interested in -1 because we have a 0-based index system. This is specifically helpful when you're doing stuff with data frames. So if you want to say like the column name or like the column names, that's the first row of a data frame. But one of the issues is if you're using Python, you need to say column 0. In R, you would say column 1 to access that thing. So just be aware that that exists, and we'll talk a little bit about how to access different components. So we can either make a new file, or if you want, you can keep going in this file. Just to keep things a little bit clean, I'm going to make a new file so we're not, you know, putting all this stuff or printing all this stuff out. So I'm going to say touch and then more strings. Now I can go back to Python focus group, session 5, and now I have my more strings.py file. So remember, I want to put my interpreter directive at the top. This helps with my syntax highlighting and making sure the command line knows what we're working with. And I'm going to clear my terminal. So here, now we're going to start looking at how it works to indexing or to index strings. So we're going to give string to index arrays. Now, if we want to take a certain letter of this, we actually need to understand how the indexing works. So let's say I want to find the A in index arrays. How do I access that component specifically? Well, we have 0, 1, 2, 3, 4, 5, 6. So this is position 6. So if we want to access that, we can say print string to index, and then we give it brackets, and these brackets tell it what position to print. So by saying 6, it's printing the 6th element. So now if we say Python 3 more strings.py, it's printing the A. But if we counted 1, 2, 3, 4, 5, 6, 7, so starting at 1 instead of 0, then we would accidentally say 7, and this would give us the R because it's shifted over 1. And the reason I bring this up is it seems very trivial now, but when you're working with anything that requires indexing, which is surprisingly common, especially across different languages, like when we start getting into the RNA-seq analysis towards the end of the course, we're going to be using indexing to access different elements of things. Whether we're in Python or R is going to make a difference. And I just want to give a quick aside too, but even though we're learning Python right now, a lot of these functionalities exist in R too. So like it's similar to a language where if you're learning English and you learn the word for apple, you now know that an apple exists and there is a word for it. So if you're looking in another language, now it's a matter of how do you say apple in this language? So it's similar in coding. You now learn what strings are and how to index a string. So now you would just say how to index a string in R, how to index a string in Python, how to create uppercase string in R versus Python. So building these tool sets makes it translatable to other languages as well. But once you have the foundation, you can kind of translate it wherever you need. So once you learn one, it's a little bit easier to go to the other one. And that's why we're focusing a lot on these fundamental aspects of the language, the tool sets, if you will. Okay. So here, I'm going to move on from just indexing a single letter, but let's say I want a section of the letters. So let's say I want this whole word, so arrays. So I can count 6, 7, 8, 9, 10, 11. I might have counted that wrong. We'll see. Oh, I did. So we'll do 12. So there we go. So now we can isolate the word arrays in this. So this is really helpful. For example, if we have, back to our genetic example, DNA sample, and we'll call it some sample.fastq.gz. What I can say is my sample ID equals index 0 to, let's say, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll say 0 to 10. And now we can print sample ID. I'm really off it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I remember why. We'll talk about this a little later, but you always add 1 to the end for some reason. And I think it is because of zero-based indexing. So you always add an extra 1 to whatever the end range is. That's something also I think specific to Python. So there we go. Now we added 1 and we have some sample. So I think during one of the earlier sessions, I talked briefly about the print function. The print function is really basic seeming, but it is helpful specifically for stuff like this where you're troubleshooting. If I didn't print sample ID and look at it and I just said, yep, 0 to 10 and then moved on, my sample ID would be incorrect across everything I do. So printing the stuff as you go is also really helpful just for debugging purposes. Like, is the output, is the variable, is what I'm doing looking like what it should be looking like? Okay, so yeah, this is an example on like, let's say your FASTQ file. And as I said, there's also other ways you can do this. So somebody else might have said, why don't you just use replace? So you can say sample ID equals DNA sample dot replace the FASTQ .fastq.gz with nothing. And if we print sample ID, that should give us the same thing. So there's a lot of redundancies and a lot of ways to accomplish the same thing in Python. So whatever way is most intuitive for you, as long as you get to the endpoint properly, is all that matters. This is why I'm sharing the different tools with you. So I also want to talk about something kind of funky, but let's say we want to access the last part of something. You can use -1. So let's say you're like, I just want to get to the last line of my CSV file and see the very end of it. I want to get to the last letter or the last entry into my list and see what that is. You can actually print, I'll go back to just indexing strings. You can print that using a -1. So -1 always stands for the last thing. So it like flip-flops and inverts. So if you do -1, it's printing the last S in arrays. And this seems also kind of trivial, but it is helpful when you're trying to look at data frames or validating that you actually added the right number of elements or the right number of things into a stored object. So anytime you're indexing, you're using this weird function. This, like, you have it in brackets, the starting thing is the beginning, this one is the end, and there's actually another optional thing that we can tag onto this. So this is called a stride. So let's say for string to index, we'll keep using string to index, but we'll put it back here just so we can see it. If I want to print every second letter of string to index, I can actually do that. So I can say every second value equals string to index. And then the first value, we can say, if we want 0, we can say go to the very end if we want, and we can say 2. So this is from beginning to end, I think. Let's see. Oh, I didn't print it. Print every second value, and that should be better. Yeah. So we say from the beginning to the end of the word, print every second thing. So from the beginning, and then from there, it prints every second thing, which is why we see IDXARY. So you can do this in any interval you want. You can do like every 5th element if you want, and it'll print only every 5th element. So this can be nice, let's say, if you're working on something that's massive and you want to see something representative. Let's say you have a CSV of 10,000 lines. It's easy for you at the command line to look at the first 10, last 10 lines using head or tail. But let's say you want more representation. You want to see the progress throughout. So you can say like print every 10 items. So then your output is only about 100 things you're looking at instead of like 10,000 lines, for example. So this is helpful just for kind of subsampling and making sure things are working as expected throughout. So one of the fun things about this notation is here we define from beginning to end, but you can also actually exclude those and it will do the same thing. So if we say get rid of the 0 and the -1, if you just leave those blank, it will automatically assume it's beginning to end and do the same thing as before. So that's also an option. So all of this functionality with the brackets, the first thing is the first element, the second thing is the last element, and remember you just add 1 to whatever the last element is, or to simplify it, use -1 to go to the end, and then this is your stride, so every X element that you want to look at. So as we mentioned, there's several things that we can use, like several functions specific to strings that we can use. I want to touch on a little more about string properties here. So we'll say string properties. So we can actually look at the length of a function as well. So length is a really helpful function in my experience, specifically with regards to data frames and things like that. Because let's say I'm working with a data frame that's 13,000 lines long and I'm doing some sort of manipulation, adding a new column and doing something. As a very quick sanity check, I can just print the length of the columns, or the length of the data frame, and make sure that I didn't lose any data in the process. So length is really helpful for that. In this case, I just want to show you, you can apply it to strings. So we can say string to index. And this tells us that our string is 12 long. So this is nice because from a biological kind of complicated perspective, in that script I shared earlier where I was trying to search for guide RNA sequences, one of the other complications here was that I wanted to find the construct sequences. And those construct sequences are up to, I think it was like 4,000 base pairs long. So I needed to iterate through those 4,000 base pairs, and I wanted to create like k-mers of length 5 and figure out how many possible combinations of k-mers I would be looking for. So by determining the length of the sequence dynamically, I'm able to do that calculation. So that might sound complicated. It's okay if it does. But the length function is one of those things that doesn't seem like it would be helpful until you kind of start to code and you're like, oh, that is nice to see. So if you want to find something as well, you can actually find the index of something. So again, let's say I want to find the exact position that a DNA sequence might be located in. I can tell it to find something. So I can say start index arrays. It's just a variable. You can call it whatever you want. And we'll say string to index. So we're still looking at string to index. And I want to see what index arrays is at. So I want to specifically find the index for arrays. So I can print this. And it will tell me the index 6 that arrays begins at. So remember earlier when we were printing index 6 up here, it prints that first A. So it's saying that arrays is found at index 6. So if you're looking for the position of something, you can also use the find function. And if something's not found, then it will kind of just tell you the output is -1 because it's like, yeah, I don't know, I got to the end and nothing happened. So let's say the string to index will say find I'm not here. You can assign it to a variable. You can also just print it directly depending on what you feel like. I bounce between the two depending on what I'm doing. So string to index dot find I'm not here. And we know that I'm not here is not in string to index. So if we print that output, we get -1. And again, because it's like, I got to the end and didn't find it, I don't know what you want from me. This is kind of a weird behavior. You would be like, okay, the index is -1. And if you don't understand that -1 is the end, then that doesn't compute. Like that doesn't make sense. So that's kind of why it's important to understand -1 is the end of something. So as I mentioned earlier, there's so many different data types that we can have. So as a quick example, let's say string operations. There's mathematic operations that we're going to learn a little bit later, but for now I want to demonstrate how they're different. So let's say example 1 is 3 and example 2 is bird. So we're going to print example 1 times 3. And what would you expect from this? So just a quick note that if you're multiplying something in Python, you just use an asterisk. So if we do this, we see 3 times 3 is 9. What do you think happens if we multiply bird by 3? Well, example 2 times 3. It literally just says bird, bird, bird. It does it 3 times. So the reason that this is important, and data types in general are important, is because let's say we are doing math here, and I accidentally read in a data frame where one of the columns that contains numbers is actually formatted as a string, and we don't know that, and then we do this operation, and suddenly what should have been 9 is now 333. So it is very easy to make mistakes like that if you're not paying attention to the data types that you're working with. So if it's being treated as a string, it's literally just tripling the value of the string by concatenating it to itself. But if it's an integer, it is computing an actual mathematical calculation, which is very, very different. So this is why data structures and data types matter. This is why it's important to understand all those things. So similarly, we can say, what if we have print example 1 plus 3. So now we're adding. With an integer, we see that that is 6. But if we say print example 2 plus 3, it tells you that there's a type error. It's like we cannot concatenate a string to an integer. Like those are incompatible data types. You can't add those things to each other. But the weird thing is you can actually concatenate strings to each other with a plus. So if we turn that 3 into a string, it will just do bird 3. So it'll just literally just add it to the end of it. So data types are very important. That's why we're going to be spending so many sessions going through different data types, how to work with those different data types, what to do with them. And as a final example for the string operations before we go into F strings, here's an example of just adding stuff in Python with strings. So we can say your first name and last name. You can type yours, you can type mine if you feel like, up to you. So if we type print first name, comma last name, now what it should do is print my first name and last name, which is sweet. It's printing what we're telling it to print. But now, what if we want to control the way the text looks a little better? What if we want to create different title cases, upper cases, lower cases, add text to the beginning and end of this variable? So there are these really nice things called F strings, and we're going to talk about that. So we'll say formatting strings, and we'll say method 1. So there's a really old function in C called printf, and it's really well known to programmers, but it's not really the most intuitive thing. So let's say we have text equals nucleus and number equals 3 divided by 11. So we can do this really weird thing where we say print and then percent %s. And I just want to highlight, I don't ever really use this, like maybe rarely. So you don't need to understand every aspect of this. I just want to show there's better ways to do this, but that this exists and there's a reason better ways exist. But we can say print %s, this indicates the first element of the string, and then %.3f, and that means 2 things. So the 3 actually indicates we want to display 3 numbers after the decimal point, and the f indicates that the second element is a float, A float is like a decimal, like 3 divided by 11 is some decimal. So that represents the decimal. And then we can say percent text num. So this is applying this function to text and this to the number. So if we print this, it's printing nucleus and then printing 3 decimal points of this number. So we can switch this to 2 and it will print only 2 decimal places. We can switch this to 4 decimal places and format that. It's not really super helpful, as we can see. This notation is really confusing to look at. So there's other ways we can do it. For a quick note, I do want to talk, I'll just show you the second method. I've not really used this either. I almost exclusively use this, and for the several years that I've been coding, still have had no issues with this. So I'll just kind of skip through this briefly, but you can use a string.format. So you can say format the text and number. So instead of using this percent and defining the data type as string and float, you can just use these curly brackets and then put that .3f. So similar to the .3f here, instead of the percents, you just put .3f in the curly brackets, and then it will do the same thing. So if we print that, it should theoretically do the same thing. Why did it? Oh. There we go. Yeah. So this and this are exactly the same thing. It's just how you want to format it, how you want to use the function. Like I said, there's a lot of redundancy. Now, this final method is my absolute favorite method, and it's called an F string. And it is the most intuitive, in my opinion. So method 3, F strings. We'll talk about software versions a little later, but one thing that I learned the hard way, the software version matters. So F strings were not introduced until I think it was something like Python version 3.6. And on the old cluster system, the default Python was lower than that. So I remember trying to run something with F strings and it told me my syntax was wrong. And I was very confused. So I'm like, I'm running Python and I'm literally following a tutorial. How is this wrong? So this is a more recent update because largely these are very inconvenient to use as formatted. So this is my favorite because you can just use things directly. So going back to, let's say this example of first name, last name, you can say print, and then I always just do F and then my apostrophes to initiate it. So it's the equivalent of printing a string, except you just put an F in front of it. And then you can say my first name is, and then in brackets, curly brackets, whatever code you want to write. So you can say first name. And see, now that it's in brackets, it's highlighted black because it's a variable. It's no longer part of the string. It's substituting something in here. So when I print that, it says my first name is Vicky. But if I take out those squirrely or curly brackets, it just prints my first name as first name. So literally the only difference is you put an F at the front and then curly brackets around your variables that you want to run, and it will substitute in strings for you. So I really like stuff like this because it's, I don't know, it's like one of those things I use for any progress stuff that I'm running. So if I show an example of, let's go back to the Python file we were looking at. I'm sure I have an example somewhere. Yeah. So print F, warning, construct, and then I put the feature name, sequence length. The length of the sequence is shorter than the minimum required matching. Like I'm printing out informative stuff in terms of warnings. Like I'm using the F string to put in variables to print out errors. And you might notice if you're ever running something on the command line and errors are printing out, it prints stuff specific to what you entered. And it only knows how to do that because it's substituting in variables into those strings. So that's an example. And then similar to the end, I like to usually say like save for something. So I say an F string save for name for this many cells to this output file name. So then when I run this, the last thing I should see is like saved counts for CDKL5 guide RNA1 for 13,000 cells to cells.csv, and then I can see the output. So F strings are, I think, the most useful and most intuitive. And basically anything in here can be code. So you can say example of another F string and say 3 plus 3 is, and then you can do 3 plus 3. And when you run that, it computes it for you. So anything that is in the curly brackets can be any sort of Python code. You can straight up print an entire data frame in here if you wanted to. So when you're formatting strings, I recommend like just know that there are ways you can do things with like decimal points and things like that, but the easiest way to do it is just an F string. An F at the beginning, put your string and then whatever code you're running in curly brackets. So I think that is the end of the material I have for this session. So I will pause here and take any questions from anyone. Most of today was just focusing on string operations, which as we get to stuff later for like RNA-seq analyses, you'll see the benefit of understanding the different data types and how to use them. But right now it might seem not super helpful. All right. I guess if you have no questions, you can feel free to go ahead and head out. If you have any questions, you can go ahead and stay and we can chat a little.
Thank you, Vicky.
Thank you.